I will start with this weather thing in the beginning, because I'm now a bit puzzled, because there are two things. One is how the weather in the time when you catch the insects affect the trends. And the other thing is how the weather has changed during these last 20 years, right? So how to disentangle these two things, right? Because, of course, the weather also could change during these years where it was collected. So the decline would be kind of real because of this changing weather. So how do you deal with it?
Mm-hmm. So first of all, the decline is true.
Okay,
so yeah. My point is not to say, but if I talk, and even Hallmann never talked about diversity.
No. I'm speaking about biomass only.
The biomass decline is true.
Okay.
By the raw data, you see that. There is, and the most fancy thing for me as an entomologist is that they could show that there was almost a decade of negative biomass. And it was not linear. If you look on the raw data, it's like, let's say, 17 years, more or less the same, and then it dropped down rapidly, and then it was on the ground for a while. And this is what we can see in the and when you say, okay, change, this is exactly what we call anomalies. So we always, the problem is species are adapted to the local climate conditions, the community. And if you are in the mountains, you have more rain, and they are adapted to that. So the interesting thing is it rather wet compared to the mean, or dry, or is it rather hot, or and so on. And therefore we call these anomalies. And I was not allowed, in this talk, I talked a bit about climate change, but my climatology expert, she would never allow me that. She said, this is nonsense, these are weather anomalies. We always, as ecologists, we are very sloppy with climate change. Data from 30 years, she says, is nothing about climate. They would call it after 100 years climate change or something like that. So the thing is, the funny thing is that the biomass can easily be explained by a few parameters. And the second thing is, if you ask entomologists, they say, yeah, but all the species have different life cycles and have different host plants and so on. But nevertheless, they are all synchronized. And from that point on, of course, I every year check, even in this exceptional year, it was exceptional in Lucanus cervus. It was exceptional in Euphytra maturna. So even in single species. So in principle, I would today say biomass is a good indicator of general well-being of insect population in a specific year. And this is determined by a complex interaction of what was in the winter, what was in the year before, and what is in the season itself.
And the increase since 1970 is also real then?
It is there.
Yeah.
And even other data, like from the biodiversity exploratories, after our paper, they reanalyze, they say, oh, we see also an increase.
Yeah, okay. So basically the whole trend is not just given by different windows, but by real weather changes during the
weather conditions.
Weather conditions.
Yeah,
exactly.
Yeah.
Okay.
Yeah.
Okay, good.
And for me, it's important to say, it's important to note, we did no data mining. And what I learned is, I would say the data set by Hallmann with 27 years is the best in the world. From biomass, there's no longer data set. Very well reported, very specific on each site and from this day to this day. But even this is too short. So there are many combinations which are possible we haven't seen in the data. So I would not say, I say this is a first glance on the story. It was sufficient to explain a strong pattern, but still I would not say we understood. For example, we cutted all the data for the mountains because the Hallmann data have no mountain data. And even if I was inspired from my mountain observations, we cutted them because mountains are different. because like precipitation there is a totally different thing. So the butterflies in my garden are adapted to high precipitation, and we need more data to have to model, let's say, in Central Europe the biomass. It's not possible with the HANDA data.
Okay. Maybe I have then a related question, because I'm still puzzled with this thing. So you basically just said that this decline the decline of the biomass was basically 20 years ago, right? Something like this.
In the beginning of 2000 it started, and then it was roughly a decade.
Exactly, and then it
there was an increase.
And and everything can be attributed to weather, but is there any explanation why the weather changed in this? No, you probably cannot provide.
We discussed that. So the observation that we have more dry winters is, so we see that more dry winter, the event of dry winters, warm winters, is increasing during the last 50 years, something like that. Mm-hmm. If you are located in the mountain area, so the Shumava mountain, you told me by yourself, no snow in the winter. Yeah. In February on the summits in last winter and 2 years ago, this is very exceptional. And people in my region are not aware that they have seen a February without snow on the Lusen over the last. But this is only one aspect. There are many other things like this. Something which is very obvious is this very warm April. Is also something which is, I would attribute it to climate change, but I'm careful.
So which would lead to the increase of biomass again?
Depends. If it is warm but wet, increase.
Okay.
So that's exactly the point. That is how my statistician says, this is the reason why you need multivariate models. Because this is exactly what they even tried in the original paper. They try to explain it with a single variable. And say, okay, it's the mean annual temperature. They fail. Even without data, it's not possible. So it means that these 10 years negative decade was in 3 years by this combination, in this 3 years by another combination, in another 3 years by another combination. And if you look only on one, if you ask an entomologist, they say it's clear. If you raise caterpillars, for example, then you are very well aware that, oh shit, the winter was bad, the spring was bad. And this makes the story so complex for the insects, or why they are then so sensitive, and even why they respond so synchronized. And one thing I did not mention, it's even from my perspective, is a very important point in that. The weather conditions are regionally synchronized. So often, like in southern Germany, it's all the same, it's all very dry winter, or so on. And when we come to, because we talked before about Ilka Hansky's metapopulation theory, this theory has the idea that, as in our landscape it is, many populations have a patchy distribution, but then the extinction and invasion happens randomly. So they extinct somewhere and they come in. But if all experience the same negative effect by these weather conditions, then the model does not fit anymore, because there is no independence. And this might explain why some small population went to extinction just because they were dropped down for a while, and all others, which might the source for the recolonization, experience the same. Even if the habitat looks exactly the same. And if you go for rare species, most of our threatened species have small populations.
Oh, yeah. Hey, I thought still maybe a little bit of discussion. So thank you for nice presentation. You were talking about this landscape, beta diversity, homogenization, especially of the forest because of the past human management. But I have a question regarding the future. What should we do? Like we have totally changed the way we manage our forests over the last 300 years. We abandoned all the traditional, active historical forest management. We don't have any natural big grazers. On the other hand, there is a lot of land abandonment, a lot of rewilding activities going on. And there are many biologists, especially in this country, but I think it's generally discussed all over Europe that actually this rewilding, land abandonment actually goes again towards the landscape homogenization and decline of the species. And as a result, actually, there was quite a high opposition against the new national park that is supposed to be established in this country. It's in the central Bohemia. I don't know if you know it, Křivoklátsko, relatively low elevation forest dominated by the oak and beech. And there was a lot of opponents against this establishment of this national park because of the opinions that this abandonment of management and this rewilding will actually lead towards the homogenization and closing of the canopy of those forests, and actually then the biodiversity decline. So I was wondering if you have this kind of debate in Germany, because you also trying to establish new national parks, but also you have quite a lot of subsidies for the active forest management, and if you are, or how you are trying to make this kind of balance,
Yeah.
If it's a hot debate, or if you have any solution or suggestions,
Yeah, it's a good question. So I think there are arguments for both sides. So what we see is if we set aside very stable systems, so mid-aged, mature, broadleaf forests, then there's the risk that they just homogenize further during the next 100 years. This is one scenario, ending up what you mentioned, and the regrowth. On the other hand, and traditional management like coppicing with standards or pastures create a heterogeneity on the other hand. But what we saw in our national park, which was very dominated by mature spruce forests, disturbance did a great job to heterogenize the forest. So I would follow both strategies in parallel. So we have a lot of space to play around with cattles, but on the other hand, with cattles without wolves, it's also boring. Also, you miss a heterogeneity, exactly the heterogeneity of a dead cow, which is important, the same importance as the dead wood. And if you run this system, something is missing. So I would follow both lines. I would support the attempt of rewilding with combining different grazers like horses and cattle. And in other areas like in ours, we miss those species. We have no real opportunity. Some people like that we put in 1,000 cows in our national park or European bison, but we need a fence then. They would immediately disappear from our area because it's not a nice grazing area. And so we have the heterogeneity by bark beetle, by windblow, by wolves, by lynx. This is one kind of heterogeneity. Other people should go for their cattle farming pastures in this way. Let's try both ways, I would say, and don't fight against each other. It's a bit a religious point on both sides. So the one believe in God and say even God should, without the big animals, he will do something, and the others believe in the cattle, but they do not like the wolves, because if you run cattle things, they are not so happy if the wolves build a third gradient in that. So I would say everything which increases heterogeneity in this system is very positive. One thing which is often ignored is from my perspective, even the ungulates are overestimated in most areas. What we miss are the floodplains. What? Floodplains.
Floodplains.
So originally the floodplains created the heterogeneous forest landscapes, and we have no knowledge because we lost all of them. They are in channels now, and all the famous studies on these large ungulates, like Jens Christian Svenning, he nicely showed that the highest density of these species was around the floodplains, and the Šumava is not a suitable area for European bison, it's hard to keep them there. They will run down to the Danube. That's a bit the tricky thing. So, and for the forestry, it means foresters are very much into selection of tree species combination for the future. And I would say this is only half of the story. The forest structure is the second half. And it's much easier to manipulate a structure than to establish new tree species. We can believe in new tree species like Lebanon, cedar, things like that. This is the dream of German foresters now. But what we learned even, or Pseudozuga menziesi, is an old dream in Germany. It worked quite well. What we learned from invasion biology, if you increase the amount, the number of bark beetles on this species increased proportionally. So you cannot, we have to go?
No, that's some automatic.
So we cannot expect, foresters always believe there is this one tree species, which is like the iron tree species against drought, against insects. And what we learned is this does not exist. So nature takes always over the resources. If you put corns, if you create cornfields, you raise the corn pests. And there's always someone in nature making use out of the resource. So I would clearly claim for more diversity of tree species and in parallel more diversity of forest structure. And this more diversity in forest structure is, for me, is a long gradient, more from this small scale I have shown up to your pastures, if you think about that.
Okay. Yeah?
So I have some particular question. What is so special with these fungi living on dead wood that they have the opposite pattern? You said that it's overcompeted by one species, so does it mean that it's so simple substrate that they cannot diversify the strategies, or what's behind it?
I think that the basic strategy in these fungi is when they colonize such a tree, it's to get there, to build your mycelium, and then, as you can see, they make these black lines to defend themselves. So they are very competitive and compete against each other, and this makes them so special. This is not so common in nature. So we see in many taxonomic groups, we see more habitat filtering, clustering patterns. So over-dispersed patterns are not that common. And fungi are one of them, really, because they fight for the resource, and they are very effective in that. Because they can grow very big, even it's always difficult what is an individual to measure in fungi. But
however, so the dominant was the first one there? So that was the massive and
in the Shumawa, this is or in this mountain, the famous is Fomitopsis pinicula. It's well adapted to the conifers there, and we studied that in another paper and showing that they come dramatically early and they stay extremely long. And with that, they occupy the resource, and this is the reason why on these bark beetle areas, this is all dominated by this fungus.
But I would kind of continue with this. That's your explanation is like postdoc, explanation of the observation. So, of course, they do this because they are competitive. But why? I don't know. Saproxylic beetles are not that competitive. They also compete for the dead wood, and also So
first of all, our observation, I showed data from the Shumawa, but for the fungi, this is shown even in very nice experiments, even in the Petri dish. So in all scales, we can show that from Fukami, with very selected, and then he combined different fungi species, and he showed exactly the same pattern we showed from our observational overall data. So this is it seems to be a very strong pattern. And the question why the insects do not show is, our explanation is they do not expose the deadwood so much. Though they eat not so even in folivores, It's rare that your folivores eat the whole tree. There are some situations, but very rare. So all herbivory on plants, often I would say, what I know from even from the tropics with a lot of defoliation, I think below 10% of the whole resource is used, which is a minority. This means there is still enough for more. So this is not a limiting factor. But for the fungi, they occupy the log totally. So there is no space in this log without fungi. And this might be the reason that they are so... No?
No. Yes, but still, you could ask, continue asking, why it is the case,
No parasites or is fungi.
I agree, but you still can ask, okay, why?
Why particularly in fungi, you mean?
Yeah, exactly. Why fungi are able to utilize the whole wood, but insects are not. We know that it is the case, but
it's a good question. So,
but we know that, of course, animals typically utilize only tiny fraction of plant resources for sure. But and it is often explained in terms of various defense mechanisms of the plants and so on. But still, then you could ask why the defense works for this. And of course, the defense doesn't play a role in dead wood. So still, it's not like you cannot fully answer it.
No,
right?
Yeah. The interesting thing is when we look often in our studies, we study both bacteria and fungi in parallel, and the bacteria are totally different in their behavior. They are more like insects. They use it. They are driven by microclimate and so on. There's not that much interaction. While the fungi always show this strong interaction. I think you have this interaction, the second group you have, this is in plants, where you have a clear fight for light. And then you have strong and there even you can show this nice over-dispersion, locally, native, non-native, and so on and so on.
Okay. Any?
One more question. Maybe similar question, but with this climate change and the crisis of the forest management, there's this big debate about close to nature forest management, how this will solve everything. But I think that you also had a quite intensive debate in Germany that it's like a close to nature forest management can lead to another homogenization of the landscape, because here many actually nature conservationists, they believe that this close to nature forest management and this selection forest is actually the best what we can do actually for the forest and for the biodiversity. So I remember there were some studies and quite intensive debate about that this is actually not true, and how it's now in Germany. Like, did you adapt somehow this discussion, and do you have some kind of a solution for
maybe
you said about heterogeneity, but did you transform to the system for the forest management?
Just an explanation for the non-forest ecologists here. So there's this debate if you have this so-called planter forest, where you have small and big trees and medium-sized trees all on the same patch. It's like an ideal world for many, even conservationists. And what we learned is this is very artificial, so nature would never do it. So in a natural forest, this phase exists, but it's very small amount, because always trees try to outcompete the others for light, and then they just grow up, and this does not exist. Foresters know that, and therefore by specific logging they create this artificial structure. From an economic point of view, this is a very cool technique, because even if some trees die, you have already the next generation established, so no big risk, even under drought or bark beetle and so on, because the bark beetle eat not the small ones. But from biodiversity perspective, and then people thought, oh, this is also cool for biodiversity, and if you look on Robert MacArthur's results, you would expect, yes, it is true, but in fact it's not, because we learned that if everything is such has such high local heterogeneity, then it's all the same all over the space. So there's no place with light on the ground and no place with these mature trees like a hall with free space for myotis foraging, such an example. For such an example, and now people recognize that in Germany more and more, and I think we are now on the way to go further from these traditional multi-layered everywhere. I would say, yeah, people are more and more aware that this is not. It's not good for biodiversity and even not for climate change, because it favors specific tree species only. So you end up with three species maximum. And if they are then on the risk by some change by droughts, then you have no big insurance. So many of our drought-tolerant tree species cannot exist in such a silviculture system.
It seems to me that like it follows from it that the only problem is really like homogeneity in this respect of like one rule for big pieces of land, right? Because as you shown, crucially it was my major impression from your talk that there are always winners and losers, right? And it is more or less balanced, and it is not that easy to make like really significant harm, that there will be too many losers and too few winners, unless we do something very, we say, okay, everything will be like this,
Yeah. So the German way. So there's a nice book I can highly recommend if you're interested in the bark beetle. There's from maybe a US journalist, Empire of the Beetle. And it starts in the Bohemian Forest and ends up in the conifer forest of the northern hemisphere. And he said these sanitary felling or bark beetle control is an export from Germany to the whole globe. And he also shows very nicely in his book that the claims and statements are always the same. So very classical thing is there's no evidence. And the common excuse is, if we wouldn't have intervened, it would be even worse. Something like that. Or, yeah. So, but to summarize what you said is, yes, I think I would recommend a landscape with different patches, not within the patch. So, and sometimes the ownership is some guarantee for that. So we have a lot of small-scale ownerships, and they are very different. Some are interested in wood, some are interested in old trees, and so on. And then at the end, you have a very heterogeneous landscape. If it would be allowed by law that even some have cows in the forest and so on, and this would make the landscape probably the best, as you said, with the winners and losers.
Yeah. Okay. So, no other questions. So, thank you very much again, and we can move to the restaurant and continue.